welcome to a video lesson of higher order differential equation. These kinds of equation in which trigonometric functions are involved are solved a bit differently than those where trigonometric functions are not involved. Let's say we have a function f(x) equals to trigonometric function, let's say any trigonometric function, let's say cos ax plus b. Now to find its solution we need to know y equals to yc plus yp. Now yc is complementary function, okay, and yp is particular integral. So we can find yc by finding roots, and yp, let me show you how you can find yp. Yp equals to 1 over f of d f(x). Now here dn equals to dn over dxn. So let's solve this equation. Yp, one second. Yp equals to 1 over f of d. Fx was cos ax plus b. You see, this is where the function came from. Now after doing this, if you see you have to replace d, you have to replace d square by negative of a square. If as soon as you replace this in the equation, if, let me write it, f minus a square equals to 0, then what you're going to do is yp equals to, you're just going to multiply equation by x and and you will just take you'll just differentiate the fd once everything will be same. And if this thing again happens, then you are going to take another x, multiply equation by another x and take another differentiate it again. This is how you can find yp. Let's solve an example. Now after you find this, you have to replace d again. So then you have to solve yp. Let me show you by a problem. Okay, let's say d square y over dx plus 9y, this is a 9, equals to cos 2x. Now let's find yc by finding roots. We know that the d square over dx square equals to d. Let's call equation d square y plus 9y equals cos 2x. Taking y as common, d square plus 9 cos 2x. Let's take, to find the roots, we need to take f d equals to 0. Let's call it lambda square plus 9 equals 0. Y y when y is going to the that side of a is equal to, y will be cancelled, so we will cancel y. Lambda square equals to -9, taking square root will become lambda equals to plus minus 3 iota. So these are the roots of our equation. Now to put it in yc, our yc would be yc equals to c1 cos 3x plus c2 sine 3x. This is our yc. We have our yc. This yc is, we have applied the complex rule yc, complementary function of complex roots. Okay, let's find yp. Yp equals to 1 over our f of d was d square plus 9. Our f of x was cos 2x. So replacing d square by negative of negative of square of a, where a equals to 2. So negative of a square would be -4. Let's replace it 1 over -4 plus 9 cos 2x equals to 1 over 5 cos 2x. Now our yp equals to 1 over 5 cos 2x. This is our particular integral. We know our particular integral and our complementary function. If we sum up these, we will get our general solution, which is y. So let's add them. yc equals to c1 cos 3x plus c2 sine 3x. Okay, y, let me change color. Y equals to c1 cos 3x plus c2 sine 3x. Our yp is plus 1 over 5 cos 2x. So this is our general solution to our equation. Thank you for watching this video.